Hello everyone, welcome back to my channel. My name is Santos G. Tolosa. So for this day, we will do the all activity in chapter 4. But before that, we need to read the introduction of the chapter 4, which is the network access. So to support our communication, the USI model divides the function of the network of data network into layers. Each layer works with the layers above and below to transmit data. Two layers of the OSI model are so closely tied that according to the TCP/IP model, they are in essence one layer. Those two layers are the data link layer and the physical layer. On the sending device, it is the role of the data link layer to prepare data for transmission and control how the data access the physical media. However, the physical layer controls how the data is transmitted onto the physical media by encoding the binary digit that represent the data into signals. On the receiving end, the physical layer receives signals across the connecting media. After decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. This chapter begins with the general function of the physical layer and the standard and protocol that manage the transmission of data across local media. It also introduces the function of the data link layer and the protocol associated with it. So for now we go to the activity in chapter 4. So we need to find it. Okay. So this activity. So this activity is the physical layer terminology. So the instruction of this activity is description of the physical layer are provided in the table. Drag each physical layer term to its description. So number one, so media that uses pattern, microwaves and represent bits. So I think the answer this is wireless. Okay, we need to check it. Okay. Number two, the capacity of a medium to carry data. So I think the answer in this is bandwidth. Okay, let me check it. Okay, then media that uses pattern of light to represent bits. So I think it is fiber optic. Okay, so we need to check it. Okay, then the measure of the transfer of the bits across the media. I think the answer is throughput. Okay, check. Then the media that uses electrical pulses to represent bits. Then the answer will be copper. Okay, we are done in this activity. Then we go to another activity. Just find it here. Okay, like this. So the title of this activity is excuse me, copper media characteristic. So the instruction is UTP, STP, and coaxial copper media characteristic are provided in the table. Click the appropriate field to match the characteristic to the media type. So we need to check it here. So number one, so attaches an antenna to wireless devices, can be bundled with fiber optic cable for two-way data transmission. So I think it's coaxial. Number two, counters EMI and RFI by using shielding technique and special connectors. So I think it is STP or the shielded. Number 3, most common network media, it is UTP. Then number 4 is terminate with BNC N types and F types connector. I think it will be Koshal. So we need to check it if it is correct or wrong. Then we need to click the check button. Okay, it is correct. It is correct. Okay, we go to another activity. Go to 4.2.2 if there's an activity here. Okay, for topic 4.2.3. So this. So the title of this activity is fiber optic terminology. So the instruction of this is description of fiber optic media are provided in the table. Click the appropriate to match the description to the fiber optic cable. So we need to help data travel approximately in 1.24 miles or 2 km per 2000 miles. So I think correct. Okay. So uses light emitting diodes as the data light source. I think it is multi-mode. Okay. Then uses laser in a single stream as a data light source transmitted. So it is, I think it's single mode. Oh, let me check it. Okay, it's correct. Then number 4, used to connect long distance telephony and cable TV application. So I think it's single mode. I think. Then okay, it is correct. Then can travel approximately 62.5 miles or 100 kilometer or 100,000 meters. So I think it is single mode. So okay, it is correct. Then use within a campus network. I think it is multi-mode. Okay, okay, it's correct. So we are done in this activity. We go to the another activity. Just find it in topic 4.2.4. If there's an activity here, okay, there's no activity here. We go to topic 4.3.1. There's no activity here too. Topic 4.1. Oh, there's no activity here. Then 4. Okay, so this. So the title of the activity is generic frame field. So the instruction is drag the generic frame field to its correct location on the diagram. So we go to data. I think data is in this. So we need to check it if it's correct or wrong. Okay, it is correct. Then types. Okay, check it. Okay, it's correct. Then the header. Okay, it is correct. The trailer. Okay, it is correct. The control. So control, I think in this place is the control. Okay, it is correct. Then the packet data in this place. Okay, it is correct. Then the addressing in this place. Okay, it is correct. Then the frame stop. I think it in the last part. Last stop. Okay, it is correct. Then the error detection here. Then it is correct too. Then the last is the frame start. Okay. Okay, it's correct. Okay, we are done in this activity. Oh wait, I think there's activity here. Another. Okay. So in this activity, the title is generic frame field. So the instruction is drag and drop generic frame field to its description. So number 1 contains the IP header, transport layer, PDU, and data. So I think it is data. Then identifies the layer 3 protocol used by the LLC. Then I think the answer is type. Then mark the end of the frame. No, that's not it. Okay, this identify the source and destination host by MAC address. It is addressing. Then specify flow control service. So the keyword control, then I think the answer will be control. Then we need to check it. So it is all correct. So we are done in the activity of the chapter 4. We need to read the summary and the conclusion of the chapter 4. So the conclusion and the summary of the network access. So the TCP/IP network access layer is the equivalent of the OSI data link layer or the layer 2 and the physical layer or the layer 3. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. The physical component are the electronic hardware devices, media, and other connectors that transmit and carry the signal to represent the bits. Hardware components such as network adapters or the NIC, interface and connectors, cable materials, and cable design are all specified in the standard associated with the physical layer. The physical layer standard address three functional areas. Physical component, frame encoding techniques, and the signaling method. So using the proper media, it is an important part of the network communication. Without the proper physical connection, either wired or wireless communication between any two devices will not occur. Wired communication consists of copper media and fiber cable. There are three types of copper media used in networking: unshielded twisted pair or the UTP, the shielded twisted pair or the STP, and the coaxial cable. So the UTP cable is the most common copper networking media. So the fiber cable has become very popular for its interconnecting infrastructure network devices. It permits the transmission of data over longer distance and the higher bandwidth data rates that any other networking media. Unlike copper wires, fiber optic cables can transmit signals with less attenuation, and it's completely immune to EMI and RFI. Wireless media carry electromagnetic signals that represent the binary digits of data communication using radio or microwave frequency. The number The number of wireless and enabled devices continue to increase. For this reason, wireless has become the medium of choice for home network and is quickly gaining in popularity in enterprise network. The data link layer handles the exchange of frames between nodes over a physical network media. It allows the upper layer to access the media and control how data is placed and received on the media. Among the different implementation of the data link layer protocol, there are different methods of controlling access the media. This media access control technique define if and how the nodes share the media. The actual media access control method used depends on topology and media sharing. LAN and WAN topologies can be physical or logical. It is logical topology that influence the data of network framing and media access control use. WANs are commonly interconnected using the point-to-point, hub and spoke, or mesh physical topologies. In shared media LANs and devices can be interconnected using the star, bus, ring, or extended star physical topologies. All data link layer protocol encapsulate the layer 3 PDU within the data field of the frame. However, the structure of the frame and the field contained in the header and trailer vary according to the protocol. So that's all for today and see you in my next video. Bye bye.